Namaste everyone, welcome to the class again. Now here let us see the second question. Question is one kind of cake require 200 gram of flour and 25 gram of fat, and another kind of cake requires 100 gram of flour and 50 gram of fat. Find the maximum number of cakes which can be made from 5 kg of flour and 2 kg of fat, assuming that there is no storage of the other ingredient. There is no shortage of the other ingredient used in making the cake. So that means from 5 kg flour and 1 kg fat, you have to check the maximum number of cakes we can make. Okay, two kinds of cake are there. So one kind of cake, other kind of cake. So here let us assume that let our solution, okay, I will say let number of first kind of cake, I will say first kind and second kind. First kind of cake is X, and similarly number of second kind of cake is Y. Okay, we have to find maximum number of cakes we can make. So Z, I will consider Z as the total number of cake. So total number of cake, suppose we represent this with Z. So therefore Z is equals to X plus Y. Z is equals to X plus Y. Now I will put this information which is given in a tabular form for better understanding. So I have first kind cake, this ST, let us write here, first kind cake, then we have second kind cake, okay. Now two ingredients we are using, one is flour and other is fat. Okay, you can give heading. Okay, now first kind cake, how many first kind cake we are making? X number, and second kind cake Y number. Here we can write total availability. So flour for first kind of cake, it is given that 200 gram of flour and 25 gram of fat. So 200 gram of flour and 25 gram of fat, the unit is in gram. And for second kind, 100 gram of fat and 100 gram of flour and 50 gram of fat. So this second cake is little heavy to digest, more fats we are using, 50 gram of fat. Total flour which is required is 5 kg and fat required is 1 kg. So here the total requirement is 5000 gram and here it is 1000 gram. Okay, so this is the information given. Okay, so what we have to do now, I will first mathematically formulate the problem. What we have to do here, we have to maximize Z, that is total number of cake should be maximum. So we have to maximize Z is equals to X plus Y. Now few conditions it should satisfy. So subjected to, what are the conditions? First condition is that this 200x plus 100y should be less than or equal to 5000. Now how I get this 200x? So for 1 cake I need 200 gram of flour. So to make x cake I need 200 gram. So that is I need 200 x. And similarly for second kind, for 1 cake I need 100 gram. So for y cake I need 100 y. And they together should be less than 5 kilogram, that is 5000 gram. Okay, because I have flour required is flour available with me is 5 kg only. So this 200x plus 100y should be less than or equal to 5000. That is, okay, we can simplify it further. That is, I divide them with 100, I will get 2x plus y less than or equal to 50. So this is considered first inequation. This is also called constraint. Okay, resource constraint I can say. Now in the same way for fat we have 25g plus 50g, so 25 and 50. So also I will say that 25x plus 50y should be less than 1000. That is, now with 25 I divide, so that is x plus 2y is less than 25 4s, so it becomes 40. So this is my second equation. First equation is 2x plus y less than or equal to 50. Second equation is x plus 2y is less than or equal to 40. Okay. Now we have one more constraint, that is x and y, they should be non-negative, that is they should be greater than or equal to 0. This we consider third constraint. So here in word problems, first we have to mathematically formulate the problem and then we can solve them. So now we have to plot the graph. So first we will consider 2x plus y less than or equal to 50. 2x plus y less than or equal to 50. So to solve this we consider 2x plus y is equals to 50 and find 2 points which satisfy this. So for that if I put x 0 I get y as 50. When I put y as 0 I get x as 25. Similarly I have one more equation, x plus 2y less than or equal to 40. Now 2x plus y is less than or equal to 50, that means origin side is the required region. So here now second equation is x plus 2y is less than or equal to 40. So here we consider x plus 2y is equals to 40. The 2 points, okay, here when I take x 0 I get y as 20. When I take y as 0 I get x as 40. Okay, so let us draw these inequations on the graph and try to find out the feasible reason. So here 2x plus y equal to 50. Now 0 comma 50, so 0 comma 50 may be somewhere here. Let us say this is 25, this is 50. On this axis we have 20, 40. So here I can mark as 20, here I can mark 40. Means for x axis and y axis we can take different scales. Okay, now 0 comma 50, so this point, and 25 comma 0. Acha, along x axis I want 25. Okay, so this 2040 will not work, or what we do better, instead of writing 2550, better we will make few smaller divisions. We make divisions like 10, 20, 30, 40 and 50. Here also 10, 20, 30, 40 and 50. Okay, then 25, 0 comma 50. So 0 comma 50 is this point. Okay, and 25, 0. So 10, 20, 25 will be somewhere here. So this point is 25, 0. Let us join them. So something like this we join, and this area will be feasible region as we have 2x plus y less than or equal to 50. So this is my solution region. Now I have to see first quadrant only for my solution because x and y both are greater than 0. Now second, we have 0, 20. So 0, 20 this point, and 40, so 10, 20, 30 and 40, 40, 0 this point. So I will join these 2 points also. So let us draw a line. It will go something like this. Okay. Now my feasible region in the first quadrant, if you see, because here also I have to see here on this side, because origin is satisfying both the n equations. You can put 0, 0, you will get it is less than 0 is less than 50, you will get 0 is less than 40. So 0, 0 origin is satisfying both the n equations. That means origin is lying in the solution. So you have to consider the part, okay, the side on which origin is, okay, for both the equations. Now equations, these 2 equations are, let us write these 2 equations on the top of it. So here it is, the first equation which we consider is 2x plus y is equals to 50. The second equation is x plus 2y is equals to 40. X plus 2y is equals to 40. Now my feasible region, I will shade it. So this area, okay, this area is feasible region. Now here we have point A, we have point O, we have point B, and let us take this point C. The coordinate of point C is unknown, so let us first find the coordinate of point C. Coordinate of point A, O, B we know. So here A is, we have first we have taken this is 10, 20, 20, 0, 20 A. B we have 10, 20, 25. So 25, 0. O we have 0, 0. And C we have x, y, question mark. We have to find the coordinate of point C. So to get the coordinate of point C, what we will do? To get coordinate of point C, solve 2x plus y equal to 50 and x plus 2y is equals to 40. So these 2 equations I have to solve. Now I will use, let us use elimination method. So I will say that from 1, y is equals to substitution method. I will say 50 minus 2x. Put y is equals to 50 minus 2x in second equation. So from first I find the value of y and I will put this value of y in the second equation. So my second equation will become x plus 2 into y is 50 minus 2x is equals to 4040. I will consider this equation as third equation. Okay. So x plus 100 minus 4x is equals to 40. So therefore x minus 4x is minus 3x is equals to 40 minus 100 is equals to minus 60. So therefore this gives me the value of x as 20. Put x is equals to 20 in equation 3. So y is equals to, equation 3 we have y is equals to 50 minus 2x. Y is equals to 50 minus 2 into 20, that will give me 10. So therefore my point C is 20, 10. So here the coordinate which I am getting for C is 20, 10. Now I have all these points. Here I have written A, B, C, D. Before that you must write shaded area is the feasible region. Better na? Shaded area is feasible region. What is feasible region? The area where you get the solution. So shaded area is the feasible region. Okay. Now my shaded area is feasible region. Here I got point C also. So A, O, B and C. Now I have to find the value of Z at these points. So I will draw a table. Okay, I am drawing table here only. So here we have corner point, then we have value of Z. Now value of Z, what is the equation of Z? We discussed x plus y. Okay, so Z is x plus y. Corner point, the various corner points we have is A, which is 0, 20. We have O, which is 0, 0. Then we have B, which is 25, 0. And then we have C, which is 20, 10. Now the value of Z, here I get 20, here I get 0, here I get 25, here I get 30. Now as this is a bounded region, okay, feasible region is a bounded region, the value of Z which we got here, they represent minimum and maximum values. So what is the maximum value we are getting here? Z is equals to 30 is the maximum value. So this is our maximum value. So I will say that therefore Z max is 30 when x is 20, y is 10. This is our solution of the problem. Yes. Simple problem. What are the different steps involved here? Is first you read question properly, understand it, then convert it in some tabular form. Okay, it is not necessary that you convert in tabular form, but I always prefer to convert it in tabular form as it gives me a better idea of the problem. Then mathematically formulate the problem and then solve the problem. Okay. Now let us see one more question. A factory makes tennis rackets and cricket bat. Okay, so two items a factory is making: tennis racket and cricket bat. A tennis racket take 1.5 hour machine time and 3 hour of craftsman time in making, while a cricket bat take 3 hour of machine and 1 hour of craftsman time. In a day, the factory has the availability of not more than 42 hours of machine time and 24 hours of the craftsman time. What number of racket and bats must be made if the factory is to work at full capacity? And second, if the profit of the racket and on a bat is rupees 20 and rupees 10 respectively, find the maximum profit of the factory when it work at full capacity. What number of racket and bat must be made if the factory is to work at full capacity? To work at full capacity means to make maximum number of items, to utilize time properly. And second, we have given some profit, and based on that profit on racket and bat, I have to find the maximum number of profit that we get. So let us consider here that factory makes X number of tennis racket and Y number of cricket bat. So I will say let factory makes X number of tennis racket and Y number of bats. Okay. Now I will first write the information in tabular form. So I have two things. One is tennis racket and I have bats. Here we have considered that X tennis racket and Y bat we will form in the factory. Now two resources we are using, one is machine and one is craftsman. Its working hour. So machine, to make a tennis racket, it is given a tennis racket take 1.5 hours of machine and 3 hours of craftsman. So here it is 1.5 hours of machine and 3 hours of craftsman. And to make a bat, 3 hours of machine and 1 hour of craftsman. So 3 hours of machine and 1 hour of craftsman. Availability. So availability of machine is available for 42 hours. क्या दिया है? In a day the factory has available of not more than 42 hours of machine time and 24 hours of craftsman. So 42 and 24 hours. This is the availability. Now the first part is that what number of racket and bat must be made if the factory is to work at full capacity. So that means I have to utilize craftsman's time and machine time to its full capacity. So I will say that when first part when factory run at full capacity, so total machine time we utilize is 1.5 times X plus 3 times Y, and this should be equal to 42 because I am using at full capacity, all 42 hours should be utilized. In the same manner, 3x plus y should be equal to 24. All the craftsman time should also be utilized. So I have to solve these two equations. So for this, what we will do? Multiply equation 2 by 3, or I will say that from equation 2, again I am using substitution method. So from equation 2 we can find the value of y as 24 minus 3x. Now I will put y equal to 24 minus 3x in equation number 1. So equation number 1 I will get 1.5 x plus 3 into 24 minus 3x will give me 42. So therefore 1.5x plus 3 4s are 12, 3 2s are 6, 1 7, 72 minus 9x will give 42. So therefore 1.5x minus 9x is minus 7.5. x is equals to 42 minus 72 is equals to minus 30. So therefore I have the value of x as minus 30 divided by minus 7.5. So this minus minus will cancel. This 35 divided by 7.5, let us multiply by 2, so it becomes 60, this becomes 15, and 15 4s are 60. So the value of x is 4. So therefore value of y from equation 3, let us consider this equation as 3. I get y is equals to 24 minus 3x. Y is equals to 24 minus 3 into 4. So that is 24 minus 12 is equals to 12. So value of y is 12, value of x is 4. X is 4, y is 12. So I got the value of x and y. Now we have the value of x and y. So I will say that therefore when factory run at full capacity, it will produce 4 tennis racket and 12 bats. This is when it is running at its full capacity. Now the second part of the problem is, if you see second part of problem, in the second part it is asked to find number of racket and bat to be made so as to have the maximum profit. So in second part I will say that let Z be the total profit. Now here we can add one more line for profit and see what profit we make on tennis racket and bat. So on racket we have a profit of 20 and bat we have a profit of 10. So here 20 and here 10. So my total profit will be 20x plus 10y. So Z will be 20x plus 10y. Now we have to maximize, here we have to maximize Z equal to 20x plus 10y subjected to now few conditions. Subjected to what are the conditions? First condition is my 1.5x plus 3y should be less than or equal to 42. 1.5x plus 3y should be less than or equal to 42. That is, I can say that 3x plus 6y is less than or equal to 84. Okay. This I will consider, we can divide them by 3. So that is, we can say that x plus 2y is less than, so 3 2s are 6, 2 24, 3 8s are. So I will consider this as equation, already 1 2 3 we have used, so let us consider this as equation 4. Also we can make one more inequation, that is 3x plus y less than 24. 3x plus y less than or equal to 24. So this is fifth condition, and x comma y this is greater than or equal to 0. Now I will plot these in equations. So first x plus 2y less than or equal to 28, x plus 2y less than or equal to 28. So for this I will consider equation as x plus 2y is equals to 28. Now here x and y, okay, I will, when I take x as 0, I will get y as 14. When I take y as 0, I will get x as 28. So this is one value I get. Similarly, I have one more equation, that is second equation is 3x plus y is 24. 3x plus y is 24. So 3x plus y is less than or equal to 24. So we consider 3x plus y equal to 24, and here again we make, now when we take x as 0, okay, I get y as 24. When I take y as 0, I will get x as 8. X is greater than 0, y is greater than 0, that indicates that I should see in the first quadrant only. Now let us draw the graph to represent this situation. So we have taken, okay, simple, okay, fine. So this is our required graph. Let us move it somewhere here. Okay, now I have to plot, everything is in the multiple of, they are not coming in multiple of any number. So what to do? You can take 2, 4, 6 like that, or we can take 4. So here, okay, I am making points by considering 4, 8, 12, 16, 20. Along x-axis we have till 28. So let us extend further, 20, 24, 28. So this is 28, this is 4, then this is 8, then this is 12, then this is 20, like this. Here also we have 4, 8, 12, 16, 20. So this is 4, 8, 12, 16, 20. Now 0, 14, along x 0, along y 14, I will see this point. It will be between 12 and 16, so somewhere here, this is the point. 28, 0, this is the point. So let us join them. So this is something like this. This is x plus 2y is equals to 28. Now we have another line, 3x plus y 24. For this we have 0, 24. So along y-axis we have 24. So we will see here 24. Then we have 8, 0. So 8, 0 is somewhere here. This is 8, 8, 0. So 24 and 8, 0. So my second line will be something like this. And my feasible region will be this area. Again, I mark this as point A, this as O, this as B, this as C. Okay. So I will say that this shaded region is the feasible region, or shaded area is the feasible region. Okay, shaded region is the feasible region. Now to know the coordinate of point C, because other so we can find out from the graph, to know the coordinate of point C, we solve now two equations. We solve x plus 2y is equals to 28 and 3x plus y is equals to 24. 3x plus y, this gives, now in the last section we have done this. This gives x is equals to 4 and y is equals to 11, right? x4 and y11 we have got now. Now x4 and y12, x4 y12. So our point C is 4, 12. So here we will make a chart of corner point and value of z. Now we have corner point A. Corner point A is 0, 14. Corner point O is 0, 0. Corner point B, if you check B, is 8, 0. And corner point C is 4, 12. Right, 4, 12. C is 4, 12. So let us mark here. Okay. Now find the value of z. The value of z is 20x plus 10y. So it is 20x. Z we will say 20x plus 10y. So here z I will get 10 into 14 is 140. Here I will get z0. Here I get z as 8 into 20, 160, and here I will get z as 4 into 20 plus 10 into 12. So this will give me 80 plus 120. 80 plus 120 is 200. 200 is the value of z. Now out of this, what is the maximum value? 140, 0, 160, 200. 200 is the maximum value. This is maximum. So I will say that therefore z max or maximum profit is rupees 200 when x is 4 and y is 12. X is tennis racket. So when we manufacture 4 tennis racket and 12 bat, then we have maximum profit, and that maximum profit is of rupees 200. Okay. So like this, all the problems are there. Okay. You can solve problem one by one. Okay. At least NCERT take 2 problem, you should solve once. Solve all the problems. Okay. Otherwise, check my next lecture. In that we will see few more questions. Thank you for being with me in this lecture.